Let me do example number 4 real quick. It'll go by real quick, and then you guys can get started on your homework. We're given f of x is equal to -2 comma x minus 1 squared plus 3. So again, I've got my vertex, which we say is h comma k. Remember that this is ax minus h squared plus k. So yeah, it would be 1 comma 3. Well, that's cool. My line of symmetry is x equals 1, right? The only other thing is what happens with this 2, the -2.
Flips it.
Flips it. So this is going to go down like this, right? All right. So I'm going to shift. In this case, I have a horizontal shift of 1 unit to the right and a vertical shift of 3 units up with regards to the vertex. Where is the vertex originally? 0, 0. So my parent function, y equals x squared, the vertex is 0, comma 0. And then this vertex, we're going to go 1 unit to the right and 3 units up. So let's graph it and see if we're correct. So I come in here, and we're going to flip it because of the -2. This becomes -2 minus 1 squared plus 3. Oops, I forgot to do the 1. 1. Let's graph it and see. So I go 1 unit over, up 3, and then flip it upside down. Okay?
And slope.
Huh?
The slope of 2.
No, it's not a slope of 2. That only applies
Isn't that the stretch part? That would be
if it's an absolute value, but the slope changes, right? So let me show you this.
For a straight line, this is a curved plane. So
If I
No.
well, it's not. It is, but it's not called a slope.
If I do the tangent line of this at 1, okay, that's the slope at the peak. Now, if I do the same thing, the slope is 0 basically, but if I do the same thing of that function at, say, 3, okay?
Different slope.
See how the slope changes? So on a quadratic, the slope is constantly changing. If it was an absolute value function, then yes, that would be the slope. The a term is the slope, but not in this case. That doesn't apply here. Okay? Any other questions?